Okay, everybody. So picking up from last day. So at the end of last lecture, we had just created 3 different classes. The classes have nothing in them except their fields. So we know what information the classes contain. But the classes can't do anything at the moment. So what we want to do next is we want to add features to our classes so that they can actually do something. Right? So we came across this term called encapsulation. Right? So in object-oriented programming, that term means you're bundling data and methods together. You're bundling data and the methods that use the data into a single unit. Right? In Java, that typically means bundling things into a class of some kind. Right? Right. So now we want to deal with constructing the object. Right? So we want to deal with object initialization. So this is what happens when an object is born. Right? When an object is born, you use, to create an object, you use the new operator, and then you call a constructor. Right? Now, what do you call a constructor for? Well, the constructor's purpose is to initialize the state of the object. Right? So what should a constructor do? Every constructor should do the following. It should set the values of all of the non-static fields of the class to some appropriate values. Right? So you want to initialize the state of the object by setting the fields of the object. Right? What does a constructor look like? It always has the exact same name as the class. Right? So that's how you can tell it's a constructor. It never returns a value, not even void. Right? That's the other way you can tell it's a constructor. Right? Constructors are not methods, even though they look like them. Right? And how do they look like them? Well, they have 0 or more parameters. Right? So you can call a constructor very similarly to how you call a method, right? Except you can only do it by using the new operator. Right? So there's no way to call a constructor manually without using new. Okay, so a constructor must be called whenever a new object is created. So that's the rule in Java, right? If you make a new object, a constructor is called. Now the funny thing is, if you go back and look at the classes that we had, they don't have any constructors. So they don't have any constructors, but we can actually use them. Right? So you can actually make a point-to object, you can make a counter object, and you can make a stopwatch object, even though they have no constructors defined yet. Right? But I just told you that you have to call a constructor when you make an object. So what's happening? Right? In Java, if a class has no constructors, right? So if it defines no constructors on its own, then the Java compiler silently inserts a no argument constructor. So the compiler magically makes one for you if you don't have one. Right? The one that it makes is called the no argument constructor. It's called the no argument constructor because it has 0 parameters. Right? To call it, you don't have to pass in any information to the constructor. Right? Now, what does this thing do if it has no information? Right? So the no argument constructor initializes the state of an object to some well-defined state chosen by the implementer. Right? So whoever made the class gets to choose what are they going to initialize the object to if someone calls the no argument constructor. Right? Now, the compiler makes one for you if you don't have any constructors. So what does the compiler-generated no argument constructor look like? If you have a primitive type numeric field, that gets set to 0. If you have a primitive type Boolean field, that gets set to false. And if you have any reference type fields, those get set to null, right? Where null means no object. Right? Okay, so our point2 no argument constructor, we want it to set the points, we want it to set a point, we want to set the coordinates of the point to 0 and 0. Right? Now we know that the compiler generated one will do this for us, right? But I'm going to put it in anyway to show you how to implement a constructor. Right? So what does a constructor look like? So its name, right? Its name matches the class, right? It has no arguments, no parameters inside the round brackets, right? And the round brackets are required, right? It returns nothing, so there's nothing in front of point2. Right? And there's an access modifier in front of the constructor. So public means that anybody can use this constructor. And for now, all of our constructors will be public for the time being. Okay, now what's inside of our point2 class? Well, our point2 class has 2 fields. right? It's got this field x and it's got this field y. If you want to refer to, okay, so the scope of these two variables is the entire class. So anywhere inside the point2 class, you can use the names x and y, and those refer to the fields x and y. Right? So if I want to set the fields x and y to 0, I can write x equals 0 and y equals 0. Right? But here I've written this dot x and this dot y. Okay? Now, what is this weird word this? So this, every non-static constructor, or not, every constructor and every non-static method, you have a parameter called this. Right? You don't have to declare it inside the round brackets. It's there automatically. Right? So every non-static method and constructor has something called this. This is a reference to the object that's currently being initialized. Right? So when someone calls a constructor, this constructor right here, right? Then that word this refers to the object that was just made by the new operator. And that's how the virtual machine knows that's how the virtual machine knows which objects x to set and which objects y to set. Might be clearer if I show you a picture. Okay. So here's what happens when you make a new point2 object. Right? So when I write point2 p, right, you get a variable p somewhere in memory. Right? It has no value yet. Right? But you get a variable p. Right? Now you call new point2. Right? So step 1, a reference variable p is created somewhere in memory. Step 2, new allocates memory for a point2 object. Right? So somewhere in memory, a point2 object appears. Right? It has its fields are uninitialized. Right? Now, how do we initialize the fields? Well, a constructor runs. Right? So the point2 constructor is called by passing the memory address of the object. Right? So we're going to pass this number 600, I guess the memory address 600, to the constructor. Right? And inside the constructor, the word this refers to that address right there. Right? So inside the constructor, right, the constructor has a hidden parameter called this. Well, it's an undeclared parameter called this, right? So it doesn't appear inside the round brackets. Right? And its value gets set to 600A, right? So the address of that object right there. Right? Now the constructor runs, setting the values of the fields this x and this y. Right? Right? So up to this object up here, right? Because it has this reference to this, it knows it has to go up here and set that x and that y to 0 and 0. And then the value of p is set by the set to the memory address of the constructed object. Right? So new returns that address back to the caller, right? And so that's 600. Right? So the value sitting beside p in memory is the address 600A. Right? So that one line of code, right, causes a whole sequence of events to occur. Right? Okay, does everybody understand what this means? Right? So this is a reference to the object that's currently being initialized. Right? And that's how the virtual machine knows where to go in memory to set the fields of which object. Okay, so for the counter, right? Remember the counter is this thing that counts starting from 0 up to integer max value. Right? So if we want to, for the no argument constructor, it makes sense to initialize the counter to 0. Right? So our counter's got a field called value. Right? That field is usable anywhere inside the class. Right? In our constructor, we just set this dot value equals to 0. Right? In this case, value equals 0 also works. Right? So if you leave off the word this and you refer to a field name, the compiler can figure out that you mean that field right there. Right? So the word this is not necessary right here. But shortly you'll see an example of where it is necessary. Okay, so what happens again? Right? One more time. So when you write counter C equals new counter, right? You get a reference variable C, pops up in memory somewhere, right? New allocates memory for a counter object, so a counter object appears somewhere, right? Every counter object has a field called value, so it's sitting here uninitialized, right? The counter constructor is run, right? The counter constructor gets the address of the object that was just made, right? So inside the counter constructor, there's the parameter this, right? Its address, it knows that the this refers to the object at 550, so that object right there. Right? The constructor runs, it sets the value to 0, right? Which value does it set to 0? This value, right? So this value to 0, right? And then the value of C is set to the address of the object that was just created, right? So the value, the reference value stored in C is the address 550. Okay, now how about the stopwatch? Just to remind you what this looks like. Oh, that's going to take a while to get to. Where is? Here. Not. Oops, sorry. And not that either, please. Thank you. Just to remind you what the stopwatch looks like. Right. So our stopwatch has 3 fields. Right. It's got the start time that you get from nanotime. It's got the stop time that you're going to get from nanotime. And then it has a field called isRunning that tells you whether or not you've pressed the start button, but you haven't pressed the stop button yet. Right? So our constructor needs to set these 3 fields. Right? It needs to set the start time, the stop time, and isRunning. Okay, so in the no argument constructor, I'm going to choose to set the start time to 0. I'm going to set the stop time to 0, and I'm going to set the stopwatch to be not running, right? Because it doesn't make sense to create a stopwatch it doesn't make sense to create a stopwatch and have it run automatically. Right, so that's easy. We've got these 3 fields. Our constructor simply sets the start time to 0. Right now, the start times are long, which is why you have to write 0L here. You could just write 0 there. That would work too. If you want to set it to a long value of 0, just add the L after the 0. Right? The raw stop time is also 0, and isRunning is false. Right? So it's not running. Okay, so there's how to implement the no argument constructor. Right? Pick some default values for your fields. And then your constructor simply sets those fields to those default values. Right? It's easy to do. Okay, methods. So a method is something that performs some kind of computation. Right? Sort of looks like a function in Python. A non-static. Now, so we've been implementing static methods in the class so far. Right? Now, most of the methods are going to switch to non-static because most methods in Java are non-static. So a non-static method can use any field belonging to an object in a computation, right? So a non-static method can use all 3 of these fields in the stopwatch class. Right? Okay, so for example, we can provide a non-static method that allows the user to set both the x and y coordinates of some point, right? So in the point2 class, I'm going to create a method where the caller can set the coordinates of the point. Right, so what does this look like? Okay. I'm just going to check if I have to. Okay, so the method has a name. It's called set. Right? It has an access modifier here. It's set to public. Right? So this means anybody can call this method. Right? It's going to return a reference to a point2 object. Okay? It has 2 parameters, both double. Right? So new x is the new x coordinate for the point. Right? New y is the new y coordinate for the point. Right? Now, what do I want to do with this? What do I want to do in the method? Well, the method is supposed to set the coordinates of this point to new x and new y. Right? So this x equals new x. Right? This y equals new y. Now, what does it return? Right? So if you look up here, right, the method says it returns a reference to this point. Right? So it returns this. Right? Returns a reference to the point. Right? Returning this will return a reference to the, I just want to check something quickly. Okay, so returning this lets you write code as follows. Right? You don't have to return this. You can return void, and that would be OK. But if you return this, you can do stuff like the following. So point2p equals new point2. Right? And now you can call point2, you can do p set. So I'm just going to change it to 1, 1. Right? Now set returns a reference to a point2 object. Right? So that's going to return a reference to p. Right? Which means you can now do something like dot that's x. I just want to find a more interesting method. I don't, oh, I have one here. Well, that's not that interesting, but and I guess up here I can write double x equals. Right? So because set returns a reference to the object, you can use it to call another method. Right? So I can set the coordinates to 1, 1, and then I can ask for its x coordinate. Right? If you don't return a reference to the point, okay, so if you change point2 to void, and if you get rid of that, the return statement, right, then you're stuck with doing something like p.set 1, 1. And then you can't do anything with the return value because it doesn't return anything. Right? So then you have to write double x equals px. Right? So by returning a reference to the point, you let the user chain a bunch of method calls together. Yeah?
Well, is that after you've done this constructor? Or is this before?
Constructor was called here. Yeah. Right? So the constructor is called to make the to initialize the object. Okay, so you can add a bunch more methods to this class, right? And if you make such a class, you're probably going to add all of these methods. So if you want to just change the x coordinate, right? Pick a name for the method. So I'm going to call it x, right? It has a parameter new x, so that's the new x coordinate of the point, right? Just like the previous method, it's going to return a reference to the point2 object, to this object, right? So now you just write this x equals new x and return this. Right? So now you have a method that lets the caller just change the x coordinate. Right? You can do the same thing for the y coordinate. Right? So this method just lets the user change the y coordinate. Right? These are all very similar, right? We're just modifying the values of the fields. Right? So all of those methods that I just showed you are what are called mutator methods. So any method that changes the state of an object is called a mutator method. Right? So these methods all change the values of the fields of the point. Therefore, they're mutator methods. Okay, so an accessor method is a method that returns information about the state of an object, but it doesn't change the state of the object. Right? So it returns some information about the state of the object, does not change the state of the object. Right? Now, if you're letting someone change the coordinates of a point, or if you're providing a point class, you almost certainly want to let the user get the x and y coordinates. Right? So we can provide methods that return the x or y coordinate of a point. What do they look like? So I can have two methods with the same name in the class. Right? Notice this method name is x, right? As long as they have different parameter lists. Right? So we have a method back here, right? That's x followed by double, right, as its parameter. We now have a method here called x that has no parameter. So that's fine. Right? Two methods with the same name but different parameter lists is OK. Right? That's fine. Right? This one's going to return a double, so it's just going to return the x coordinate of the point. Right? So this method's easy to implement. You just return this dot x, right? Because that's the x coordinate of this point. Right? For y, you just return this y, because that's the y coordinate of this point. OK. So that line, the first line of all the methods that I've been showing you, right? So that line right there, public double y, right, is called the method header. Well, it's sometimes called the method header. Okay. So the method header is always made up of the following parts, right? So you have one, the modifiers, so public, right? Two, you have a return type, right? So here it's double. Three, you have the method name, right? So there it's y. Four, the parameter list, right? So the stuff, the round brackets and whatever's inside the round brackets. And then five, you may have a throws clause, but we're not going to deal with that right now. So this, you only need this if the method throws what's called a checked exception, right? And I'm not going to tell you what a checked exception is for some time. So ignore 5 for now, but it can be there if you want it to be there. Okay, so for the set method, the modifier is public, right? The return type is .2. The method name is set. The parameter list is double and double. Right? The names don't matter in the parameter list. Right? So all you care about are the types. So it's double, comma, double. So the parameter list, well, no, I tell you it's a list of types and names. So I guess here it's the list of types and names. It actually doesn't include the names, but anyway, we'll go with the names. So it's the list of types and names that appear inside the parentheses. Right? The names must be unique. Right? So you can't have an X here and an X here. Right? So duplicate parameter names are not allowed. Oh, here's where the parameter types, here's where the names don't matter. So every method has what's called a signature, and so this is fairly important. So you have to get this straight. So the signature consists of the method names and the types in the parameter list. Right? So that method right there, its signature is set double double. Okay? So you don't care about the parameter names when you talk about the signature. You also don't care about the return type. Right? So that's important. Okay, so what other signatures are there? So here's your method in string, right? So it says it returns a string, its name is 2 uppercase, right? What's its signature? Well, it's just the name of the method, right? Followed by the types in its parameter list, so there's no types, right? What about char at int x? So the signature is just char at, and its type, so int, right? Index of. Signature of that method is the name, so there's index of, plus the type, and the second type, so string comma int. Right, and the last one, get cars, its signature is get cars int, array of car, and then int. Right? Now, the rule in Java is that the signatures in a class must be unique. Right? So that's how you can have methods with the same name, right? Or that's how the compiler checks if you have methods with the same name, do they also have the same signature, right? So you're allowed to introduce a second method into the same class, right? So I can do set double x, right? That's okay because I only have one method, right? It's set double double, right? So set double is fine, right? That lets you set the x coordinate, right? But notice what happens as soon as you introduce this method, you cannot introduce the third method here, right? You cannot have a set double y, even though the name y is different from the name x here, right? So set double x, what does it do here? Why did I write that? That's interesting. This is supposed to set the x coordinate of the point. That's supposed to set the y coordinate of the point, right? But you can't have both these methods in the same class because they have the same signature, right? And that's why the methods were named x and then double x and then y and double y, right? They have different names, therefore they have different signatures. So two or more methods with the same name but different signatures are said to be overloaded, right? So in the, here I've just made up some methods. I don't think they actually exist in the .2 class, right? If you wanted to write a method that computes the distance between the point and another point, x, y, right? You could add 3 different methods here if you wanted to, right? So this tells you the distance to another point whose coordinates are float values. right? This tells you the distance to another point whose coordinates are double values, and that tells you the distance to a point that's a point 2 object, P, right? So those are all fine because they all have different signatures, right? And we say that distance 2 is an overloaded method, right? Same method name, different signatures. Okay, so all Java methods have to return something, right? If they return nothing, then it must return the type void, right? Otherwise, it can return only a single type of value, which is one of the big differences between a Java method and a Python function. Right? A Python function, you can return a tuple of values, right? Java, you're stuck returning a single value, which is really inconvenient sometimes. But that's the way the language was designed. Right? So public double x, that has a return type of double. Right? So it must return a double value. Okay, so now you know everything about the method header. Right? You know that it has a modifier, you know that it has a return type, you know that it has a name, you know that it has a parameter list. Okay, now there are methods that are common to all classes, whether you define them or not. Okay? So our point2 object, it only has a few methods in it that you change the coordinates of a point. But it turns out you can do other stuff with the point2 object, even though we don't have methods defined for it yet. So in Java, every class is what's called a child class of java.lang.object. Right? So now we're going to talk about these child classes when we get to inheritance, but that's in part 3 of the notes. Right? So that's in a few weeks still. Right? But for now, what you need to know is that every class that you create has all the methods that are in java.lang.object. Right? So whether or not you define them, they're there. Right? So you get all the methods that are in the object. Right? Now, if you look inside the object class, you'll see that there are, last time I checked, there were 11 methods. Right? Only 3 of them are of any interest to us right now. Right? So there's a method called toString, and there's a method called equals, and there's a method called hashcode. Right? So the toString method is the method that should return a textual representation of an object. Right? So if you write, okay, so when you call toString on an object, it returns a string representation of that object. Right? Now, that string representation should be readable to a human. Right? And it should make sense for the object that you're creating, or for the class that you're creating. Right? So if I have a point2 object, P, and I set its coordinates to -1, 1.5, right, I might want its string representation to look something like that. Right? So round brackets, -1, comma, space, 1.5. Right? I want something that's nice and readable to a person, and it looks like a point. Right? And that sort of looks like a point. Okay, so you go ahead and implement toString, right? So if you call toString on this point using our class right now, you're going to get out some gibberish, right? So the gibberish doesn't mean anything to anybody, right? But it does work. So if you write system.out.println p.toString, you'll get something, right? You get something, you get the object version of toString, right? I want to replace that version of toString so that I get something like that. Right? So up here it says toString should return a string representation of this point. The string representation of the point is the x and y coordinates of the point, separated by a comma and a space inside a pair of parentheses. Right? So that's the contract that I have to satisfy inside this method. Right? So toString always looks like public string toString. Right? That's always its method header. Right? Now how do I implement toString? Well, I need to make a string that looks like that. Right? So I need to start with a round bracket. Then I need the x coordinate of the point. Then I need a comma and a space. Then I need the y coordinate of the point. And then I need the closing round bracket. Right? So there's the opening round bracket. That's the x coordinate of the point. There's your comma and a space. There's your y coordinate of the point. And there's your closing round bracket. Right? So just use string concatenation to build the string and return the string. right? You've got this funny @ override sitting up here, right? So @ override, anything that begins with an @ in Java is an annotation, right? So an annotation modifies the thing that it's in front of, right? So this annotation modifies this method called toString in some way, right? Some other tool is able to read the annotation and decide what this means, right? In this case, that annotation tells the compiler that you're replacing the toString method that you got from object with this version of toString. Right? So here @ override is optional, so it doesn't have to be there. Right? It's an optional annotation that tells the compiler we are redefining the method toString that we inherited from object. Right? Now when you put this thing in front, right? So when you put that annotation in, the compiler will actually check the signature of this method. Well, the signature and the return value, actually. Actually, it checks everything. It checks the signature, the return value, and the access modifier. It'll actually check all of those to see that they match the method that was defined in object. Right? So now if you go back and look in object, you will see that the method header is public string toString. Right? If it doesn't match, the compiler will flag this as an error. Right? So it'll tell you this is not a correct override. Right? In this case, everything worked fine. Okay, now, why do you do this? Right? Because you want users of your class to be able to easily print out strings. For example, if they're debugging, right? Or for the debugger to print out a nice representation of your string, of your point, sorry. Right, so I can make a point, I can set its coordinates, and then I can print the string. Right, using p.toString. Okay, moving on to the counter class. Right, so what methods do you want to put in the counter class? Right, so let's see. I have a counter. It's counting up from 0 up to some number. It's probably useful if you can get the value of the counter. Right. You want some way to tell the counter to go up by 1. Right. So you want some method that tells the counter to, hey, count up, right? And then we want something that gives you a string representation of the counter, right? Okay, so this is pretty easy. There's our constructor, right? There's our no argument constructor sets the value of the counter to 0. Here's our accessor method that gets the value of the counter, right? Returns an int, right? Its name is value, right? What do? Well, you just return this value. Okay, now what about this counter, the one that counts up? Right? So our counter counts from 0 up to some number, right? And we originally decided that it's going to count up to integer max value. Okay? So the method will increment the value of this counter by 1. If the method is called when the current value of the counter is equal to integer max value, then the value of this counter is set to 0. So in other words, it wraps around. But it doesn't wrap around like an int wraps around, right? It wraps around to 0, right? If this was just a plain old int, it would wrap around to integer min value, right? But here we actually wrap around to 0. So now we actually have to do some logic, right? So if the value of the counter is not integer max value, right? Then you can go ahead and just add 1 to the value, right? So this dot value plus plus adds 1 to the value, right? Now, if the value is equal to integer max value, the contract says it should wrap around to 0. So else, this value is equal to 0. Right? No return value, so there's no return statement. Right? So it returns void. Well, sorry, it doesn't return anything. Therefore, there's no return statement in the method. Now, what about toString? So it's up to you how you want to implement toString. Right? So as the designer of a class, it's your responsibility to decide what should the string representation of this object look like. Right? Here I've decided it's just going to print out count, colon, space, followed by the value. Right? You might choose something else. Right? You might choose square brackets in the value, or braces in the value, or something else. Right? But it's up to you. Whatever you decide, though, you should document it. Right? So you should say exactly what does the string representation look like. Right? Okay, now what about our stopwatch class? So for the stopwatch class, right? You want a method that starts the watch, right? You want a method that stops the watch, right? And then you want a method that gets the elapsed time. And you probably want to return it in seconds and not nanoseconds, because nanoseconds are awkward. Right? OK, now how do you get the elapsed time? Right? Because the watch might be running when you call the method that returns the elapsed time. Right? So if the watch is running, then the elapsed time is the time from when the watch was started to now. Right? If the watch is not running, then the elapsed time is the time from when the watch was started to when it was stopped. Right? Okay, so we got those fields, right? Start time, stop time is running. Right? Here I've got the number of nanoseconds in 1 second, right? So there's 1 billion nanoseconds in 1 second, right? I want this because, where is it? Because nanotime returns nanoseconds, and I want to return everything back in seconds. So I'm going to have to convert eventually. Right? So I create a private field in this case. Right? Whether it's private or not is debatable in this class. I've made it private just to show that you can. Right? So a private field is usable only inside the class itself. Right? No one else can see this field. Right? It's final, which means when I can only assign a value to this thing once. Right? So when I write equals something, that's it. I can't write equals something ever again with this field. Right? It's static, so that means this field belongs to the class, right, and not any individual object. Right? And now because it's a final static value, it's a final static primitive value. In this case, it represents a constant. So I can write it in all caps to indicate that this is a constant value. Right? So once again, final. I can only assign a value to it once. Right? Static belongs to the class. Right? Private means that it's usable only inside the class. Right? No other class can use the word billion or stopwatch.billion. Okay, there's our constructor. Sets the start time, stop time to 0. Right? Sets is running to false. Okay, now what? Yep. The L, right there? Okay, so if you leave the L off, and it's just a sequence of digits, right, with no decimal point, then Java thinks it's an int. Right? So it's an int literal. As soon as you put the L on the end, it becomes a long literal. Okay, so how do I start the watch from running? Right? Or how do I start the watch running? Okay, so if the watch is already running, right, this method's going to do nothing. Right? So, but if the watch is not running, then it has to get the start time from nanotime. Right? So system.nanotime, that gives you the system time when someone pressed start. Right? And then you set is running to true because you started the watch. Right? So if the watch is not running, right, set the start time, and then set is running to true. Right? Otherwise, right, do nothing. Okay, now what about stopping the watch? So if you stop the watch, you also get back the elapsed time in seconds. Right? So the elapsed time is defined as the time between when the watch was started and when it was stopped. Right? So if the stopwatch is already stopped, then the elapsed time in seconds as computed by elapsed is returned. Oh, so there's another method kicking around. So we'll see that in a second. Right? So if the watch is running, right, you want to stop the watch. So this is running becomes false. Right? And then you want to get the stop time. Right? So system nanotime tells you the time when the caller called stop, called the stop method. Right? And then I'm going to compute the elapsed time by calling the method called elapsed. Right? So here's elapsed. Right? So for a running stopwatch, the method returns the total amount of time in seconds that have elapsed since the stopwatch was started. So this is a running watch. You haven't pressed stop yet. Right? For a stopped watch, you simply compute the stop time minus the start time. Right? Okay, so if the watch is not running, oh, I see how I'm doing this. Okay, so the way I'm doing this is I'm going to get the current time, right, by calling nanotime. I'm going to check is the watch running, or not running. So if the watch is not running, the current time is just equal to the stop time, right? And then the final return time is just the current time minus the start time divided by 1,000,000,000, right? Now, it returns a double, and current time and the start time are both longs, and so is 1,000,000,000, right? So I have to convince the compiler to do all of this math using double arithmetic, which is why the 0.0 is hanging out front here, right? I need to return a double, and I need to divide two integer values, right? I know if I divide two integer values, then I get back some kind of integer value. So I need to force the numerator to be calculated using double arithmetic, right? The easiest way to do it is to write 0.0 plus the current time, right? And that computes that part there using double arithmetic. That returns a double value. Subtract another long value, so that gives you a double value. Divide by a long value, that gives you a double value, right? And that's the reason why it's written like that. Okay, so here's an example of where we're calling a method from inside another method, right? That's perfectly fine in Java, right? Okay, I guess I should ask if there's any questions so far. Anybody? No? Okay. Carrying on. More constructors. So we've only implemented one kind of constructor so far, and that's the no argument constructor, right? Just like methods, though, you can have multiple constructors, right? Also, like methods, the signatures of the constructors have to be unique, right? And what that means is because you can't change the name, all your constructors have to have a unique list of parameter types, right? So for the point2 class, it would probably be convenient if the caller of the constructor can set the x and y coordinates right away, right? In other words, they don't get stuck with the 0.00 every time. Right? So what do? You put in a method called, you put in a constructor that has two parameters, right? Double x and double y. So now the caller can set the x and y coordinates of the point, right? Okay, now here you run into a problem, right? You've got a parameter called x, but you've got a field called x, right? You've got a parameter called y, and you've got a field called y, right? Inside the method now, inside the constructor, what does the name x refer to, right? Does it refer to that x, or does it refer to that x, right? When you write y, does it refer to that y, or does it refer to that y, right? So the answer is, in Java, if you just write x, it refers to the parameter. And if you just write y, it also refers to the parameter, right? So the parameters hide the fields. I think the term that they actually use is that the parameters shadow the fields, right? So in other words, if you just write x, you end up with the parameter x. If you just write y, you end up with the parameter y, right? So if I want to set the field x, I have to write this dot x equals x, right? If I want to set the field y, I have to write this dot y equals y, right? If you write x equals x, that does nothing, right? It sets the value of the parameter x to x, right? Similarly, if you write y equals y, that just sets the value of y to the parameter y to y, right? So here's an example where you must use this, right? When you have a parameter whose name matches a field, when you use the field, you have to write this in front of the field name, right? Turns out this happens quite a lot in Java, right? Okay, so what's going on here? Right, now when I call a constructor passing in two values, right? First thing that happens is a variable p gets created, right? New allocates memory for a point2 object, so there it is, right? The point2 constructor is called, and it passes in the address, right, of the point that's being created, and it also gets the arguments -1 and 1.5, right? So when you call the constructor, you get the argument -1 and 1.5 plus the address of the object that was created, right? So this is set to 600A, right? The parameters x and y of the constructor are set to -1 and 1.5, right? Now the constructor runs, and what does the constructor do? It sets this x to x, and it sets this y to y, right? So what's this x? Well, there's this, so that's up here. This x is here, right? So this x equals that x, right? So that becomes 1. This y, so this up here, y, gets set to that y there. And then finally, the address of the object gets passed back to the caller, right? And they assign that to a variable there. All right, I'm just going to do this slide, and that'll be it. Right. So in that constructor, there are parameters with the same names as the fields. Right. When that occurs, the parameter has precedence over the fields. Right. We say that the parameters shadow the fields, and when shadowing occurs, you have to use this to refer to the field. Right. And that's why the keyword this exists in the language. Right. All right. It's 1/4 so I will end things there. And see you on Wednesday, I guess. There is a lab this afternoon if you're in the Monday lab. Hey.
Is there any way I can get like an idea of what the job will be like?
Not this minute.
Yeah, but like.
But yes, there will be a sample midterm.
Okay, cool.
Yeah.
Will it be like a written thing or will it be like a Jupyter?
So it's on OnQ.
Okay.
Have you used OnQ before? Oh, this will be interesting for you. You know what OnQ is, right? Okay, so.
I've done it on like a midterm, so.
Oh, okay. Well, then I mean, it's gonna be the same thing.
Okay, cool.
Yeah. Hey.
Yeah, that's it.
Hi.
I was hoping you could just elaborate a little